Okay class, now let's proceed to the linear equation. Linear equation is actually the equation is a very popular in differential equation since it happen to frequently occurs in many applications. So before we go further on solving the linear equation of ODE, we need to understand first the general equation of X linear equation. The linear equation is said to be the form of linear equation if you have a equation that having ax dy dx plus bx y and we have cx over here. So if you can rearrange your differential equation in terms of this form, then we can say that the equation is linear. So the things that you can consider over here, you can recognize your ax, your bx and your cx. Okay, let's say if you have one differential equation, x squared sine x minus cos x, and we have tangent x dy dx over here. So the first thing that you can do it is you can rearrange to x general form, whereas the left hand side we have a dy dx to make sure that you understand the flow. So we have a tangent x dy dx, we have plus cos x y, and then I rearrange that this x square sin x into the right hand side. So from here you can see that you will have your ax is equal to tangent x, your bx is equal to cos x, and then your cx is x squared sin x. So that you can make it a conclusion, the given differential equation is linear equation. Okay, right. Okay, so let's go to another question. Okay, let's say if you have another differential equation y dy dx plus 2x equal to 5y cubed. So according to this one, your ax over here is y, and then here we don't have y, and here we have 5y cubed. So x obviously is not the linear equation. This type of equation can be linear if you change the differential terms over here. Let's say you have y dx dy plus 2x equal to 5y cubed. So this one we can say that it's a linear because of this term should be different with this one. Means that if here is x term, then here is y terms, and if here is a y terms and here is x term, and then for the second one must follow this one, and this one is okay to have another things. So you will have a y for this type of equation is y, you have by over here is 2, and then you have cy is 5y cubed. so that you can conclude if you have dx dy over here, it's a linear for this one. Okay, this one is not linear equation. Okay, let's say if you have in another form, for example, you have dr over d theta plus r tangent theta equal to secant theta. So you need to look at the differential term over here. If here is r, and then here there is one terms of r, and here should not be an r terms over there. So from here you will have your a theta is equal to 1, b theta is equal to tangent theta, and then your c theta is equal to secant theta. So you may conclude that the given differential equation is linear equations. Okay, so the tips that you need to consider when you want to identify whether the differential equation is linear or not, so you need to check its differential terms, and then for the term that combine with the second one must have related with the differential terms over here. Okay, so I hope you understand. Then if you understand the differential equation given to you is a linear equation, now you can proceed with its procedure to solve it. Okay, class, now let's continue to identify whether the following function of differential equation is linear equations or not. Okay, so according to the definitions of the linear equation, if you can bring out what is the ax, bx and cx, so you can consider it as a linear equation. So here what is your ax is x squared plus 1, and then your bx is x, and then your cx is x. So we can say that this given differential equation is linear equation. Okay, what about the second one? The second one you may rearrange back, so you will have dy dx, so you will have 1 over x and y, and then we have x exponent x. So directly you will get your ax is equal to 1, your bx is equal to negative 1 over x, and then your cx is x exponent x. So this one also is a linear equation. Okay, hopefully you can understand, because this is the most important part before we go further for the solution of the linear equation.